Hello, and welcome to the fourth video in this series of EG168 Matlab videos. This video provides an introduction to working with loop statements and nesting loop statements, which is where you have loops in loops in loops and so on and so forth. So, let's start by looking at some of the different loop statements. A for loop will perform a string or set calculation a predetermined number of times using an incremental counter, which is set on the first line of the for loop, and when the end of the loop is reached, Matlab returns to the top of the loop. This increases the incremental counter by 1 and repeats the loop until the incremental counter limit is reached, and after the last line of the final loop will exit the main code. So for example, if the incremental counter were 1, 2, 5, it will repeat 5 times and then it would end. So, let's create an example. So we are going to start with an M file, which I have called Shining Loop, and that should give you a hint of what the string's going to be, if you know any Stephen King novels. If not, feel free to Google it. And let's initially design it to only display our string once. So for that, we can use the command display, so disp, and we want it to show our string. So in this case, that is all work and no play makes Jack a dull boy. Which in the novel was typed out on a typewriter many times, so I thought it was apt for this function, since we'll be showing it many times later on. So let's start by only displaying it once. So if we save that and run it, it displays once. So if we want to have it displayed, say, 10 times, we can change that to a for loop with an incremental counter. So let's change that to be 4. Remember, we need to keep it lowercase. Then incremental counter equates to 1 to 10. We want, in this case, to display the number of increments, just so you get an idea. So display IC counter, and then we want it to display the loop. And then after that, we have to tell it to end. So if we save that now and we run it, we have it show 10 times. You can also do that without displaying the incremental counter. You can have it showing or not showing according to the application and whether or not you want to see it. So save that and we'll run it again. Now you can use the for loop and the incremental counter to show it as many times as you like. So let's make it a little bit longer, shall we? And then run it. Now this isn't instantaneous, so we may be waiting here quite a long while, and we don't have enough time for that. So if you regret your decision and want to end it after less increments than what you've specified, you can do that by clicking Ctrl+C in the command window. So moving on to a more complex example from the handout, we can use this for function to calculate the area of a circle of multiple different radii. For that, we can create a new M file, which is area. I produced this earlier, but we'll start from the beginning to show you. After that, we'll start by simply showing how the M file can be used to produce one set radii. So for that, we type in the following: r for radius is equal to 1, and we want the area to equate to pi times the radius squared, and then at the end we want it to display the area. Make sure it's the correct case though, otherwise it won't run. So if we save that and we run it, another case of troubleshooting. We'll go over this in the next video, well, in the final video. But when we have an issue, we are told the line it's in and what the issue is. So in this case, I have mistyped. We'll go over that a bit more. If you want any more information on troubleshooting, please watch the final video. So if we save that and run it, there we have the area. Now if we wanted to move on and find the areas of circles with radii from 1 centimeter to 20 centimeters in increments of 1 centimeter, we can use the following loop. So we'll start by typing in 4 increments of radii, and we want it 1 to 20. So the area still equates to pi times r, in this case IR squared. And if we end that, we can then ask it to display A. So save and run that. And there you have it, all 20 values. And in this example we use the incremental counter IR as the index number for adding the areas, which increases the size of A after each loop iteration. However, if you don't want to use incremental values, you can specify the values to be used in a vector, and then specify the number of values in the incremental counter. So we'll do it like this. Start by specifying the values, so radii equates to, let's say, 12, 14, 18, 24, and 209. Now we'll start, I think we'll also start by zeroing the A to bring it back down. Then we'll start the for loop, so 4. There are 5 increments since there are 5 different indices. So 1 to 5. And then A in those increments still equal to pi, just a radii, so pi in the increments, and we want that squared. Then we want it to display this. And we end it. Now when we save and run this, we get our 5 values of area for the indices we have specified as radii. So if you want to try one of the other examples from the handout on factorial numbers, you can copy and paste the code into a new M file, my factorial, and I can now open one I made earlier. So we'll save that, leave it, and we will find my factorial down my list of current folders, and there we go. So here we have a for loop. So we'll look at the for loop. Which is used to calculate the factorial numbers. It will start with a number equating to 1 and multiply it by incremental numbers until it reaches the specified value, at which point the loop will end. So if we provide it with a prompt of, say, 6, so if we make sure that's saved and run it, and we'll provide it with 6, that loop should then multiply each increment by 1, by 2, by 3, by 4, by 5, and then by 6, and on the 6th increment it will end, which should produce a value of 720, which it does. If you would like to have a go with some more files, there are multiple other examples and exercises in the handout. But for now, let's move on to nesting of loops. In these examples, loops can be nested to create loops within loops. So let's look at another example from the handout. We can use nested loops to create a square of stars. So if you copy and paste the text from the M file printed stars, we can begin, or to save time, I will open one of the files that I copied earlier. So if we look for nested stars on my current folder list, I called it printer stars. There we go. We can then start this. Here we use the for loop to produce a set number of rows and columns of stars, of which value the user can define through the input commands for the rows and columns of how many stars there will be, which is then input into the for loop to specify the number of loops. The stars are produced using the fprintf function, which works like the display function, but with far more control over the way that the input data is formatted. For example, in the second fprintf command, the -n means that it goes to the next line. So if we run this, we can then create a box of stars of multiple sizes. So let's have a go with that. If we save it and run it, should we ask for 6 by 6? And there we have a 6 by 6 matrix of stars. And so that brings us to the end of this video on loop statements. The next video will be on conditional statements. Thank you for listening.